Today we're going to look at solving complex radical equations, but they're going to be more complex. And what's going to make them more complex is that we're going to see two radicals within our equation, but also we're going to see other things. We may see a constant, or we may even see a variable. So what we're going to do to be able to solve this is first isolate one of the radicals. So we're going to isolate one radical. And basically what that means is that we're going to solve for one of these radicals. It'd be easiest if we went ahead and added the square root of x minus 5 to both sides of my equation. That way I can take care of that negative. So I'm going to end up with the square root of x equal to 2 plus the square root of x minus 5. Now I can go ahead and square both sides. And what that's going to do is remove the square on the left side. So if I square this, I'm going to have to also square the right side. So the square root of x squared is x equals, here if I square this out, remember the square means I have two of them, so I have 2 plus the square root of x minus 5. So I'm going to distribute my 2, so I end up with 4 plus 2 square roots of x minus 5. I'm going to distribute my square root of x minus 5. So plus another 2 square roots of x minus 5, plus, if I take the square root of x minus 5 and multiply it to the square root of x minus 5, I end up with x minus 5. Now, I want to go ahead and take this equation and solve for the square root in order to write my other equation. So let's go ahead and do that. If I simplify this right side, I have 4 minus 5, which is negative 1, plus my x, plus 2 radical x minus 5, plus 2 radical x minus 5 gives me 4 radical x minus 5. Remember, my radicand does not change when I add, only the numbers outside of the radical. Now, to get the radical by itself, I can add 1 to both sides and subtract x. So I have plus 1 and I have minus x. So I end up with a positive 1 equal to 4 square roots of x minus 5. Continuing to solve for the square root, I'm going to divide by 4. So I have 1/4 equals the square root of x minus 5. Now I have the radical by itself. I can again square both sides. So if I take 1/4 and square it, I end up with 1/16 equals x minus 5. Solving for x, I can add 5 to both sides. So I have 5 plus 1/16 equal to x. Now, we really don't want to leave it as 5 plus 1/16, so you could do a couple different things. We can have 5 and 1/16 equals x, or we can write it as an improper fraction. 16/5 is 80, plus 1 gives us 81/16 equals x. Now, we do need to go ahead and take and plug this back in to make sure that it works. Remember, we could have extraneous solutions. So we're going to take our 81/16 and put it in for x. So off to the side, I have the square root of 81/16 minus the square root of 81/16 minus 5 equals 2. Notice I just plugged in my x, or took my x out and put in 81/16. Square root of 81/16 is going to be 9/4 minus 81/16 minus 1/5. Well, 5 with a common denominator is 80/16. So I get the square root of 1/16, which is 1/4. And I want to know, does that equal 2? Well, 9/4 minus 1/4 is 8/4. And we want to know that equals 2, and of course it does. So then 81/16 is a solution that works. Let's go ahead and look at example 2. In example 2, let's take the square root of x equal to the square root of x minus 8 plus 2. Now, notice I have a radical on both sides of my equal sign, so I can actually go ahead and square both sides. So I take the square root of x and square it, I end up with x equal to, again we have to square this out, so I can either rewrite this again, or I can remember the shortcut. Remember the shortcut is to square the first one, so x minus 8 square root squared is x minus 8. I can take 2 times this quantity and double it, so plus 4 square roots of x minus 8, and then square the last term, so plus 4. Now I can go ahead and solve for that radical and get the radical by itself. So I'm going to subtract 8, or subtract x, add 8, and subtract 4 from both sides. So subtracting x, adding 8, and subtracting 4. So my x's cancel, and 8 minus 4 gives me 4, and that's equal to 4 square roots of x minus 8. Solving for the radical, I can divide by 4, so we end up with 1 equals the square root of x minus 8. Now that I have the radical by itself, I can go ahead and square both sides. So I have 1 equal to x minus 8. Add 8 to both sides, and 9 equals x. Remember though, we got to plug that back into the original to make sure that it works. So off to the side I have the square root of 9 equal to the square root of 9 minus 8 plus 2. Square root of 9 is 3 equals 9 minus 8 is 1. The square root of 1 is 1 plus 2, and that gives me 3. So we know that it works. So 9, again, is our solution. Let's go ahead and take another look. Example 3, maybe one that doesn't turn out so nice and pretty. Let's say we have the square root of x plus 10 plus the square root of 3 minus x, and set that equal to 5. Now, if we subtract off to get one of the radicals by itself, so we have the square root of x plus 10 equal to 5 minus the square root of 3 minus x. I'm going to go ahead and square both sides, since I have the radical by itself on the left side. Again, the square root of a square is going to end up being what the radicand is, x plus 10. Here, if I multiply these together, again, I can take 5, square it, I get 25. I can multiply the 2 together and double it, so minus 10 square roots of 3 minus x. And multiplying this one to itself, so I get plus 3 minus x. Now, if I go ahead and solve or simplify first, since there's a lot over there, I have 25 plus 3 gives me 28 minus the x minus 10 square roots of 3 minus x. I'm going to subtract 28 from both sides, and I'm going to add x to both sides. So now I have 2x minus 18 equal to negative 10 square roots of 3 minus x. Notice my x did not cancel in this example like the previous two did. So now I'm going to go ahead and divide by negative 10. So I have 2x minus 18 over negative 2. Well, if we remember from our quadratic formula in simplifying, we can divide each of those terms by 2. And we're going to do that here to make our life a little easier. So I have x minus 9 over negative 5 equal to the square root of 3 minus x. Now I can go ahead and square both sides to eliminate this radical. But again, if we notice, this left side is kind of ugly. So x minus 9 squared, we're going to go ahead and square that out. X squared minus 18x plus 81 over 25, and that equals 3 minus x. Now I need to go ahead and solve this equation. Well, what do? Well, since we have a fraction, we can multiply this 25 over. So I get x squared minus 18x plus 81 equals 25 times 3 minus x. Now since we have a quadratic, we have to set it equal to 0. So we're going to take this 25 and distribute it. So I get x squared minus 18x plus 81 equals 75 minus 25x. Setting it equal to 0, I'm going to subtract 75 from both sides. I'm going to add 25x. So I end up with x squared plus 7x plus 6 equals 0. Hopefully this factors for us, and it does. So we have x plus 6 and x plus 1 multiplied together to give me 0. Now that I have two factors multiplied to give me 0, I know that I can set x plus 6 equal to 0 and x plus 1 equal to 0. Solving for x is going to equal negative 6 and x will equal negative 1. Now we want to make sure that we take negative 6 and negative 1 and plug it back in for my x's to make sure that it works. In this case, I'll tell you, it does. So on to example number 4. And what we're going to do with example number 4, we're going to just simply set it up a little different. So we have the quantity of x minus 9 to the 1/2 plus 1 equal to x to the 1/2. So notice we have those 1/2 powers. But remember, the 1/2 power is simply a radical in disguise. So we have the square root of x minus 9 plus 1 equals the square root of x. So now we can go ahead, since we have a square root by itself on the right side, we can square both of our sides. We have to just multiply this out by distributing, so we'll end up with x minus 9 plus 2 square roots of x minus 9 plus 1 equal to x. Remember, multiplying this out, we simply had 2 of them. So let me come off to the side and we can look at that one more time. So we had the square root of x minus 9 plus 1 times the square root of x minus 9 plus 1. So if I take the square root of x minus 9 to the square root of x minus 9, I get x minus 9. Square root of x minus 9 times 1 is the square root of x minus 9. And distributing the 1 through, I get plus the square root of x minus 9. And 1 times 1 gives me plus 1. Adding those together, I have x minus 9, which is what I have over here. Remember, there's a 1 in front of the radical. So 1 radical x minus 9 plus 1 radical x minus 9 gives me 2 radical x minus 9. Again, remember the radicand does not change. And then plus our 1. So now we can go ahead and simplify this left side. I have x minus 8 plus 2 square roots of x minus 9 equal to x. Solving for this radical, I'm going to subtract x, and I'm going to add 8 to both sides. So over here, the x's and the 8's cancel. So I have 2 radical x minus 9 equals, on this side, my x's cancel, which is nice. So I get equals 8. I can divide by 2. So I get the square root of x minus 9 equals 4. Now, if I square both sides, I get x minus 9 equal to 16. Solving for x is going to equal 25. Now again, make sure you take the 25, plug it back in for your x's to make sure that it works. And let me just tell you, it does. So that's going to take care of our more complex examples that I'm going to show you. Now in your assignment, you will see some more complex things, but I want you to try them and see what you can do with them without me showing you how to do them.